Hi, very good morning. Let us see how to design a combinational logic circuit using PLA. See the question. He says the circuit accepts 3-bit number and generates an output binary number equal to square of the input number. It means it accepts a 3-bit number. The output is a binary number which is square of the input. Okay, let us see the question. So we know the steps how to design a PLA. It's just 5 steps. First step is we need to make the truth table. Let us start with making the truth table. So what is my question? My question is 3. Can you see the question again? The circuit accepts 3-bit input numbers. 3-bit number as the input. The circuit accepts 3-bit number. So 3-bit number is the input. A, B and C. So it is 000, 001, 010. From 000 to 111. This is your 3 bits. After 111, it is 1000. 8 is 4 bits. So we go only from 000 to 111. So what is the decimal number of this 000? 0. 1, 2, 3, 4, 5, 6 and 7. Now what is the output? He says an output binary number equal to the square of the input number. So I need to have an output which is equal to the square of the input. So what is 0 square? 0. 1 square? 1. 2 square is 4. 3 square is 9. 4 square is 16. 7 square is 49. Just write the square. So input is 3-bit number. My outputs, if you see, what is a binary equivalent of 49? Convert 49, decimal 49 to binary, which is 110001. Convert 36 to binary, which is 100100. Convert 25 to binary, which is 011001. So just convert your squares, this decimal number to binary and fill the output. So you have 3 inputs, which is 000 to 777. What is the output? Square of the input. 0 square is 0. 1 square is 1. 2 square is 4. 3 square is 9. 4 square is 16. So this is my truth table. I have done with my truth table. These are my inputs. These are my outputs. What is the second step? Find the minimal SOP for the given function. So how many functions are there? Output functions? 1, 2, 3, 4, 5, 6. That is B1, B2, B3, B4, B5, B6. For B1 to B6, I need to find the minimal SOP. What is B1? Go to B1 and see what is in which place B1 is highlighted. There are 2 1s in B1. In which position? 6 and 7. So B1 is 1 in 6th and 7th position. So 6 and 7. Go to B2. B2. In B2 it is, there are 3 ones. Can you see this? There are 3 terms. One is 4, other one is 5, other one is 7. 4, 5, 7. B3. Go to B3. B3 is, there are 2 terms. One is in the 3rd position, other one is in the 5th position. 3 and 5. Go to B4. B4 you have ones here and then here. There are 2 ones. One is in 2nd position. Other one is in 6th position. 2, 1, 6. Go to B5. Check the ones. There is no 1. So I have given no minterm for B5. Go for B6. There is 1, 2, 3, 4. What are they? 1, position 1, position 3, position 5 and position 7. 1, 3, 5, 7. Done. Now I need to do what? Minimal SOP. How will you find minimal SOP? First I will do for B1. How many inputs are there? A, B, C. Since there are 3 inputs, 3 input K-map, 3 variable K-map. So this is your 3 variable K-map syntax. Where I need to mark 1 and 1 in the place 6 and 7. I go to the position 6 and 7, mark 1 and 1. Now group it. What is common for this group? A. What is common vertically? BC, BC bar. So what is common? B. So A and B are common. I am done with B1. Now go for B2. B2 is 4, 5, 7. Go to position 4, 5, 7. Mark ones. Now group it. So 4 and 5 are adjacent. I can group pair. I cannot group 3. I should group pair, or I should group 4 quad, or I should group 8 octet. Now here I'm grouping a pair. Can you see this? This is one pair and this one is neighbor. So I'm grouping two. There are second pair. So for this pair, what is the common thing? One and one horizontally what is common? A. Vertically what is common between these two cells? B bar, C bar, B bar, C. So B bar is common. So it is A, B bar. Done. Now see horizontally for 5 and 7. What is common for 5 and 7 horizontally? A. Vertically what is common for 5 and 7? C. B bar C, B C. So C is common. So it is A, C. Done. Now go for B3. What is B3? 3 and 5. In the place of 3 and 5, you need to mark once. Can I group it together? No, because these two are not adjacent. I cannot group diagonal. It should be neighbor, adjacent. Only then I can do the grouping. Since it is not adjacent, I'll write it as single. So what is this? A, B bar, C. Over. This one is A bar, B, C. Done. Next, what is B4? 2, 6. Position 2, position 6. Mark the ones. So what is common for this? B, C bar is common. Horizontally, it is not common. A bar, this is A. So vertically, these two belong to B, C bar. Done. Now go for the next one. There is no B5 because there is no minterm. Go to B6. 1, 3, 5, 7. Mark 1, 3, 5, 7. All ones. So all these four are adjacent together. So you can mark as a single quad. So what is common horizontally? A bar A. Both are not common. So what is common vertically? B bar C, B C. What is common? C is common. So B6 is equal to C. Now what is my first step? To make the truth table. So I've done making truth table. What is my second step? Find the minimal SOP. So from the function, I have found out the minimal SOP. Okay. So now I have minimal SOP. What is the third step? Find out number of input buffer. So how many input buffers we have? Input buffer is equal to number of inputs. If there are 3 input variables, 3 input buffers. So I need 3 input. Number of input buffer is equal to number of input variables. So A, B, C are 3 input variables. So I need 3 input buffer. Done. Now what is the next step? I need to find out number of programmable AND gates. So how will I find number of programmable AND gates? Now see the minterms. Number of minterms. 1, 2, 3, 4, 5, 6 and 7. So there are 7 total minterms in all the functions. So number of AND gates, number of programmable AND gates is equal to number of minterms, which is 7. Now what is the next step? I need to find number of OR gates. So how many OR gates I need to have? Number of functions, output functions is equal to number of OR gates. Now see here, you have B1, you have B2, you have B3, B4. There is no B5 because there is no minterms. B6. So 1, 2, 3, 4, 5. There are 5 output functions. So I need 5 OR gates. Let us start the diagram. So number of input buffers. So there are 3 buffers. Buffer A, buffer B, buffer C. This is a symbol of buffer. So what are the 3 inputs? A, B and C. To a buffer, can you see to a input buffer? This is a true form. A. This is from the bubble, if it is coming, it is a complement form. A bar. This is a symbol of input buffer. Clear? Again, buffer. This is B, true form. From inverter, from a bubble, if it comes, it is B bar. Now it is C. From a bubble, it is coming, it is C bar. Draw the vertical lines, horizontal lines. Okay. Now how many AND gates I need? 7. So draw 7 AND gates. 1, 2, 3, 4, 5, 6, 7 AND gates. And from the first buffer, draw the lines for the AND gates. Okay. Now, what is the first AND gate? What is the first function? AB. What is the second function? A, B bar. What is the third one? AC. So, write all the minterms here. So, it is AB, AB bar, AC, AB bar, C. So, write the minterms which you have generated here. 1, 2, 3, 4, 5, 6 and 7. So, write all the minterms here. Now, what is the first minterm? AB. So, connect A, connect B. Okay. Put a cross mark at A and cross mark at B. This will be AB. What is the second AND gate? A, B bar. So in the A, position A, give a cross mark. In the position B bar, give a cross mark. This is A, B bar. What is the third one? AC. In the place of A and in the place of C. Okay, what is the fourth one? A, B bar, C. So, there are three terms, three variables, A, B bar, C. A, okay, B bar and C. Can you see this is your C? This is your B bar. So you fill all the AND terms. Finally come to number of OR gates. Number of OR gates are 5. So draw 5 OR gates. 1, 2, 3, 4, 5 OR gates. So what is the first function? B1 is AB. So go to AB wire connected to the first OR gate. I am done with B1. What is B2? AB bar plus AC. So from AB bar, connect AC. Okay, so you know there are how many AND gates? There are 7 AND gates. So for 7 AND gates, you need to draw vertical lines and extend this vertical lines down. OR gates must be connected in horizontal fashion and must be connected in vertical fashion or must be connected in horizontal fashion. So now what is B2? B2 is AB bar plus AC. So go to AB bar and go to AC. Put a dot so that these two will come to second one. So see the third one is A B bar C plus A bar B C. So A B bar C plus A bar B C connected to B3. Now B4. What is B4? Check B4. B4 is BC bar. So B4 is BC bar. B5 is C. Okay. So have I done designing a PLA for the given three inputs? The outputs B1, B2, B3, B4, B5 are square of the inputs. Okay, this is a combinational logic circuit which we have designed using what? A PLA. In PLA, first step is identify number of input buffers. Second step is identify number of AND gates. Third step is identify number of OR gates. Number of input buffers is equal to number of input variables ABC. Number of AND gates is equal to number of minterms 1, 2, 3, 4, 5, 6 and 7. So number of minterms. Number of OR gates, output OR gates is equal to number of functions. 1, how many functions you have? B1, B2, B3, B4 and B6. B5 is, there is no minterm, so we are leaving it. So 1, 2, 3, 4, 5 functions. So 5 functions, B1, B2, B3, B4, B5. Clear? So this is how you need to design a PLA logic circuit. Thank you.